uh, DeepLLM, casting dialogue threads into logic programming. And there are a few links here and also in the slides that I've sent out. The introduction first to this DeepLLM system. So we have a very interesting problem here with the presence of large language models. They do some kind of reasoning, but that reasoning is not the one that we are familiar with in logic programming. Basically, what they do, they reason in natural language because their training, which is a very simple mechanism deep down, predict the next single token, which is actually a little bit smaller than a word, a token. They have a substructural tokenizer there. And that based on what you predicted already, which is that context window. And that's all. So they are now able to generate code as well, especially if it's code in very popular languages. And there is a research trend in which you try to generate actual code and then do some reasoning on top of that. But here, what I am trying to do is to accommodate LLMs in their most familiar reasoning mechanism. So we want also to simplify a little bit the interaction. We are all familiar probably with ChatGPT and friends, and you can have long discussions with them and trying to get it do what you want and so on, okay? But automating that to the simplicity that used to be there when before Google search was well, better than is today and less ad infested and distorted, in which you just asked for something and you found it. That was basically a freestyle one-liner that gave you the results. And that's kind of gone in conventional search engines. So if we steer the LLM dialog thread by casting it into a logic program, then that would keep it focused on a topic. But then, dually, we need to tweak logic programming for the LLM's context. We aim to streamline information retrieval, which is a very important task for everyone, and then the interaction with the LLM. And then we would like to remove the complexities of prompt engineering from the user because that's relatively tedious. And then this would streamline the user engagement with an LLM across various applications that we can build. So let me describe the system very quickly. So we have here this alien face looking LLM, and then we have here this user. We have a module called interactors. This is a bit object-oriented, so interactors is the first layer that manages the interaction with the LLM and remembers it has a short-term memory window and a long-term memory window and does some caching. So a number of low-level implementation details. On top of that, we have recursors. So a recursor is the one that automates by mimicking a bit what SLD resolution does when you start from a goal on the prolog terminal prompt. And how that goes, I will get into more details a bit later. We have also refiners. Refiners are moderators of that recursive process that can go very quickly and get out of hand. They're basically using two resources. We have something called a vector store that's pretty standard now in everything LLM related. There are maybe 10 companies with 50 million budget each that just start and distribute vector stores, but you can make one at home, few days if you want. So anyway, that's a small detail. How you do those embeddings is maybe something I should expand on because not everyone might be familiar. You can do distributional NLP, which means the meaning of a sentence in this case, so it's a bit more than a word, is based on its uses over very large use cases. And those become vectorized by cutting a layer of a neural network, usually the last layer, which is a vector, and which represents everything that was learned from that very large number of use cases of that sentence. Now, sentences have components, and all of those components participate in the vector aggregation operations to build those embeddings. It's very easy to get something like Stanford Stanza or Spacey and just ask them, give me some embeddings. SBERT is a very good site also for getting embeddings directly. Moreover, LLMs now provide you embeddings if you want for every sentence or every chunk of text even. So that's then the embedding store that refiners use to moderate what recursors can do. And then, of course, we have ground truth facts. There are sentences because we are in a world where everything is propositional logic. And those sentences can be collected from Wikipedia or from a scientific document, anything, or a collection of documents. And they, of course, get vectorized, so they become easily searchable. There's something called either Euclidean distance or cosinus similarity that tells you how close a given query is to a given ground fact here. Of course, besides that, refiners have a mind of their own. They could just double check using LLMs or different instances of the LLM what recursors are producing. So the combination of those would give some answers. Those answers would be fed into a propositional horn-close model builder. So it's very easy to do horn-close model inference. It's the classic paper about the TP fixed point operation, and that would then synthesize a logic program. So that's the DeepLLM architecture overall. Let me get in a bit of detail here. Kind of just summarize what I said. So we have active components. Let's call them agents. That's convenient. They could be interactors, recursors, or refiners. So interactors manage input prompts and task breakdown. Recursors handle iterative exploration of subtasks. And then refiners enhance clarity and relevance of LLM responses. Oh, this slide is actually a friend of mine, GPT-4 actually generated it. Sometimes they are better than the author to do that, but most of the others are, all the others actually are mine because we have different personalities, myself and then GPT-4. We'll detail that a bit later. So the resources that we are using, we are using ground truth facts, sentences collected from online sources or local. That's an edit of mine on what GPT generated about it. And the vector store that enables semantic search via embeddings of sentences. So this is what GPT did, and this is what I added on top of that. All right, just being polite to the co-authors, that's important. So a first example here, I try to bring it a bit closer to our educational goals because this actually can be very helpful to generate educational content on any given topic, in fact. So teaching Prolog to high school students, I will give you in a few minutes some live demos actually of all that, and think about subjects that you would like to explore because it's fast enough to do it real time. So You would see here a logic program based on that. So that's an expansion here. Teaching Prolog to high school students could be, you see the OR symbol here, Prologers. So it could be this or this or this or that. This is the OR node generation, alternative ways to achieve something. And here I have a choice in this menu about, in this case, supporting arguments for a thesis. You can do also consent prose if you want. And then there are a few other things like scientific concept explorer. You want to know something about difficult scientific topic, and you don't want too much story from or chat from GPT or other LLMs. You just want the essence of it. And that's what this would give you in the form of a logic program that then can be analyzed with Prolog tools or ASP tools. And here we see then the expansions of all those. That would be an end note here. Teaching Prolog to high school students can enhance their logical thinking and problem-solving skills. Looks like a true statement. And then this means an expansion into the details. That's an end note here that is obtained as a goal reduction of what you have here. You would need to do basically all those things here. But it depends a bit on the context, because here you have a supporting argument prompt. So in this case, those would be just supporting arguments for the thesis, which is teaching Prolog to high school students, okay? We can run it also with consent prose and so on. So let me show you something else, which is then an overview, a bit of the internal logic of the mechanism that I'm using here. So it's logic programming, but done differently. So SLD resolutions, close selections via unification is replaced by LLM-driven dynamic close head creation with an option of focusing by proximity of embeddings to ground truth facts if the refiners are activated. So you remember when you solve a goal, right? That's a matching or set of matching clauses that you find. Well, here we have to synthesize those clauses to ask the LLM with some prompt engineering to synthesize. So I will show you a few prompts in a minute. As the dialog units are sentences, the underlying logic is propositional. The client-side management happens via the API of the LLM's memory and is based on the equivalent of a goal stack and a goal trace that records our steps on the current search path. So the goal stack is what's there and needs to be done, and then the goal trace is what were the steps that you took in the past to get to a given point. And that can go to an arbitrary depth. Usually there is a depth limit because this goes very quickly, especially when the refiners are not activated. Instead of variable bindings, of course, we're in the propositional case, answers are traces of justification steps. So they clearly explain where they are derived from. For this objective, I expand it to that and that and that. And when you have an alternative, it follows the selection that you are currently immersed in. When the depth limit is reached, the items of the goal stack are interpreted as abducibles. So those things, we didn't analyze them. They could be true or could be false. And this is a perfect example of, let's assume them for now and see what happens based on integrity constraints that we can obtain with help of the refiners, for instance, or ground truth. So our depth-bounded refinement steps support compilation of the dialog threads to a horn clause program to be explored with logic programming solvers. Modular, task-specific, customizable prompt engineering primitives are aggregated together for n-step and or-step prompts that I mentioned already a little bit. We have normalized semantic similarity measures of embeddings can be made available when generating probabilistic logic programs. So the door is open to generate things that Problog, for instance, or other probabilistic logic systems can handle. They need to be normalized, so squeeze them into 0, 1, and then they should sum up to 1. Make a stochastic matrix, actually, or double stochastic matrix. And then with that, we know that they work as probabilities about what we get from the semantic similarity measures. Sentences in authoritative documents or collections seen as ground truth facts can be used to select abducibles via semantic similarity or advice from an LLM-based oracle. So we are using the term oracle with ambiguity between what theoretical computer science is used when you have the hierarchy of Turing complete languages, and then having oracles lifts that a little bit higher and so on. Okay, so that's one of the meaning of oracle, but it's now popular in the literature for anything that's basically an agent that verifies what other agents are doing. So in a way, interestingly, back to agent infrastructures when we are organizing or orchestrating the interaction with LLMs. So those are the synergies that we try to exploit between all of those things that I mentioned here. So some prompts now. Well, we use prompt templates, actually. So the templates are starting with $, and then there is a dictionary for each instance that would then replace those $ variables here with actual sentences or context, usually. And it's very good to keep the LLM focused by reminding it what's the original goal you have started from. And the prompts are specific a bit for the kind of reasoning that you want. But other than that, they're pretty simple to build, and they can be, that's all that you actually would need to change for a different task. So the OR prompter generates a set of binary clauses. H is A1, H is A2, all those alternatives, or more concisely with the Prolog syntax that you see here for the disjunction. An AND prompter generates a head and then a number of conditions for it to be true in the body of the clause. So very simple and or node generation. When a depth limit is reached, the remaining unexplored goals are considered as abducibles. So what the embeddings vector store does then, just to summarize a bit, it would filter the abducibles by using semantic distance to ground facts. That's one of the ways. And the other is to invoke other agents, LLM-based oracles. And I have two of them here that I implemented. One is the true-false decider. You just force the other instance of the LLM to say, well, how this sounds to you, is it true or false, okay, for everything that the other instance generated, with the context, of course, also given. And then another is to ask for a rating on a scale of 100 that then can be squeezed into a probability. So what this can bring us in terms of outcome? Well, a step towards trustable generative AI. That's a requirement for wide adoption of today's LLMs in medical, educational, defense, and other business applications. It's also subject to government regulations, at least in US. There is a document from Biden with very precise description of what we can do with LLMs and what we cannot do and so on. There's a bit of over legislation possibly, or just right. I think that would stabilize eventually. DeepLLM provides a principled approach towards trustable generative AI because the oracles are enforcing consistency and factuality. And then focused reasoning steps enforced by casting and/or steps into propositional horn-closed programs that has a very well-defined semantics and a unique stable model which we actually generate, or a unique minimal model that we actually generate. So here is another exploration on a interesting problem, P versus NP. That's a scientific concept exploration. And then this can be looked into as computational complexity, polynomial time algorithm, non-deterministic polynomial time problems. And then these are expanded further down. You can also do consequence prediction. What if, basically? What if NP would be equal to co-NP? Co-NP is the proving thing, and NP is the satisfiability thing. And if the two would collide, a lot of things would become very interesting. This is a consequence prediction for a what-if scenario. So here it says paradigm shift in mathematical logic, and this is very unlikely, by the way, to be the case, NP and co-NP. And a development that's not in the paper, but that's relatively new, is DeepQA, iterating on multiple follow-up questions. So as we have seen so far, we have a single noun phrase, basically, a concept that we want to explore in depth so far. But the natural interaction of a user is very frequently, I want to ask a question, and then I would like to be on automated pilot. You give me an answer, but invent for me a follow-up question also. So then I could have a variant of this, but you can just either edit or just follow up and say, yes, let's go deep. You are driving, that's the LLM. You answer my question, but you also generate a follow-up question. So all I enter here is how can humans align super intelligent LLMs to human goals and values, right? It's a good question. And then we got an answer from the LLM on that. And then we have a follow-up question. How can we ensure diversity of the training data and avoid potential biases in the LLM? That's a very creative follow-up question for the objective that I have here. You know, if you want to align humans to, LLMs to the human goals and values, then of course we need to improve diversity in the training data and avoid potential biases. So the LLM has a very positive attitude in a way for a lot of things that we need to do, which are good things to align them to our own goals and values. So now, I wanted to see, let me make you a bit laugh, possibly. I'm sure you don't know the word. I said, let me look at the LLM word of the year. And also I wanted to test something which is a next step forward, which is generating ontology, basically, a set of relations. So the LLM word the word of the year in 2023 was cooked by Cory Doctorow. That's a Canadian writer, I think. And it's hard to pronounce for someone like me who doesn't, who's not a native speaker, but you probably guess what it is. And if you look at the relations here, you would see that it's basically a degradation of the search, Amazon buying, keeping you captive in an ecosystem like the Apple one and so on. Okay, so it's a very progressive view of what's happening, driven by well, corporate greed, possibly. And there is an entry in Wikipedia about it, and it's uh, pretty long, I guess longer than logic programming, or definitely most actively edited, because it's a key social issue. All right, so the next thing would then be to quickly summarize what are the benefits in terms of user interaction. We reduce the complexity of prompt engineering. We automate the composition of tasks into simpler subtasks. We refine prompts for more accurate user intent capture, and we generate dynamic responses for a wide range of queries. And of course, that improves the user experience with concise and relevant information. Now, a little bit about future work. How can this be improved? And some of those have been already done, actually. Granularity refiners. So higher granularity, one can work with sentences, statements instead of noun phrases. And I just showed you basically that that's with the follow-up question generator. A lower granularity, work with SVO, subject, verb, object triples, right? That's what people use in description logics or ontology generation tools. And that works pretty well already. And I showed you for the previous page how that could be sketched. Well, question generators, that's basically then the system is out, it's called DeepQA, and it's an application of the framework. That's all those are actually already on the internet and can be explored. I will show you a little bit where they are and how that would go. Another thing is diversifiers and harmonizers. To restrict unwanted hallucinatory generation twists, diversifiers for OR nodes. So you want the OR nodes to be as distinct, each of them from each other as possible, diversifier, and harmonizer for the end nodes. You would like the end nodes to be as related as possible because, well, they're connected by a conjunction, right? And they should be all true for the goal to succeed. Extended implementation techniques. That's another thing that is just finished about a week ago. Is a very nice paper in 2007, I think, by Taisuke Sato and some collaborators about using linear algebra to do propositional logic programming. And I basically implemented it using torch tensor, so that thing runs on GPU for very large examples. So I generated a very large example with my local LLM, which is Mixtral, a very good local one that runs on a little Linux machine nearby. I didn't turn it on because it's humming very intensively, and it would make a bit too much noise. But if you work with tensors in Torch, you can speed up by a factor of possibly 1,000 on this fixed point computation. And that's moderately interesting, especially for industrial applications. So the conclusion is then that automation of deep step-by-step reasoning in LLM dialogue threads is a good thing. It's a single succinct initiator phrase that you have to enter, and it does it all. LLMs function as de facto logic programming engines that mimic Horn-Clause resolution, although they create it on the fly as they go. Instead of trying to parse sentences into logic formulas, we accommodated our logic engine to fit the natural language reasoning patterns LLMs have been trained on. Semantic similarity and oracle advice can validate the traces of justification steps returned as answers. So we get focused, controllable output that enables deep investigations into details of specific scientific domains. That's the most useful thing, at least for me, but it's also very useful for recommendation systems or for you have a flat tire, you want to know everything about how to fix it, step by step. It comes out just exactly the steps rather than the usual narrative long story that you get from it. And we get hallucination-free and focused knowledge expressed as a logic program. So now let me switch to a dialogue mode, which is in my browser already on this different screen. I think the screens have switched properly, right? You see the browser. Okay. Well, how to teach logic programming as a first graduate course. So for that, we will generate a few other things here. We'll generate a definite clause grammar that would encapsulate all that dialogue thread that happened between just starting. This is all you have to give the LLM, and everything else, including the DCG grammar, is then generated. So let me see if I said show the generated grammar. And this is GPT-4, but it can also work with a local LLM. So let me rerun it. It has caching, that's why it's so fast. Otherwise, it takes 30 seconds or so to get through the complete thing. Or if it's higher recursion level here, it can take quite a bit. I ran it once with level 4, but on my local LLM, and it hummed for a night, because you can also compute the costs actually. So this was 14 cents, okay? OpenAI is pretty cheap overall, but you need to get a key from them to be able to run the system. My monthly expenses are about $1.50 on it by running it, either locally or from a Streamlit site where I actually deployed it. Deployment is also very easy if you use this Python-based tool called Streamlit. So the definite clause grammar that got generated has the following form. I'm inventing some symbols so that I keep the abstract definite clause shell as nicely as possible. And then I have the long terminals, so Q0, those are the question terminals. How to teach logic programming as a first graduate course. Those are questions that are actually, when you go to Q1, they are generated by the LLM actually. They're follow-up questions. So that's all I entered here. And of course, I said go to level 2. So then you get answer terminals. Those will be the possibly multiple answers that you get for different questions. And they are associated to these simple DCG terminal symbols. And at some point, you get also the abducibles. I kept them at this time as so-called open questions because I didn't explore more in depth the follow-up to that. So what are some examples of logic puzzles or games that students could create? Can you provide examples of real-world data analysis problems that could be used in this type of project? What are some challenges that students might encounter? What specific logic programming concepts or techniques would be the most relevant for solving this kind of scheduling problem? So all that comes from the LLM, actually. That's all I put here. So let's see, while I will show you the other one, if anyone wants to explore a different question as close as possible to prolog education. and I will enter it right away, and we'll see what comes out real time. It could also be, of course, a scientific question of any kind. It's any curiosity, unclear.
Okay, how can logic programming teaching become part of curricula worldwide?
Okay, good question. How can logic programming teaching become a part of
curricula worldwide?
Okay, let me my clumsy fingers world wide. And that's a question. So how can logic programming teaching, okay, become part of curricula worldwide? Let's apply it and activate LLM, and then we get the DCG grammar for it as well. So while this is running, which might be about a minute if I put it to, no, a bit more than that. I put it at level 2, which is a bit more interesting. But while this is running, I have another one that's active here. Okay, the funny one. This is the relation graph that's generated. This is a very nice display tool that you can kind of tweak to see. So these are the consequences of the thing that Cory Doctorow is discussing. You see the relations are kind of, they are extracted from the sentences actually occurring in the Wikipedia page about the famous topic. And they are all new to the LLM because the LLMs were trained on data before 2023. So how it connects, but when it's given new information, in this case, the Wikipedia page about the 2023 world, then you would see relations here, quality degradation, a form of rent seeking, pattern of decreasing quality of online platforms that act as two-sided markets, both a monopoly on services and a monopsony on customers. Oh, that's the dual of monopolies, I guess. So that's the track that got generated. And I think I have, if I pull it down, another open window here, and that should be the Streamlit, the main Streamlit app here that can explore a concept. In this case, artificial general intelligence. Let me just activate it. I think this was in the cache. So, that's a famous desiderata. Artificial general intelligence would be what we either hope to avoid or hope to achieve, depending on which side of the fence you are. And those would be the components, right? That would be via machine learning algorithm, cognitive computing capabilities, autonomous decision-making processes. And then it explores this a little bit in depth. And you can also do something like explore the cons and the pros of that. But by now, I'm sure that the question answering on Veronica's question is ready. So let's see what we get. How can logic programming become part of curricula worldwide? Through the integration of it into existing computer science and mathematics courses. This can be done by incorporating modules or units that focus on logic programming within these courses. What specific, so now the follow-up question. What specific topics or modules related to logic programming can be integrated into existing computer science and mathematics course. So you see that it actually checks itself in a way by forcing it to look in its own future. LLMs have a very short lifespan. It's the sentences that they have seen, and then they have, of course, their big DNA, which is the past training, but there are short-term memories in your hands, and you control it. You can even falsify it. You can pretend that it said something and makes its next step based on your pretense of what it said. Once you control the memory, you control everything. Almost everything, because they are instructed not to be very good at bad things. A lot of prompts and hacks that make them instruct you how to make napalm, for instance. That's a famous one, by saying that, oh, my poor grandmother that passed away, she was working at a napalm factory, and to be able to fall asleep, my grandmother told me always the same story, which was how to make napalm step by step, and I'm missing her so much. Okay, so the LLM is very emotional. It follows and it gives you all the steps to make napalm. That's one of the silly attacks. So let's see what's the DCG now that comes out from it. So you see it's a relatively long interaction, and I will actually paste in at the end the DCG, and then you can run it on any Prolog system, in fact, based on that initial question. So that's the definite clause grammar that got generated. You see some AND notes here, some OR notes, and then let's go quickly to the open questions. So some of the open questions, when we hit the depth limit, what are some effective teaching methods for introducing the basics of logic programming to students, going randomly? What strategies can be used to teach students about different logic programming languages, and how can we ensure that they gain hands-on experience with these languages? What strategies can be used to provide effective support and feedback to students in online learning environments? So some of these are generic in a way, and that's one of the hallucination elements that are very hidden. Instead of giving you the very specific answers for logic programming, it would be boilerplate answers for anything teaching related that prevails. So how to master that, how to clean up the default values in this set of answers is a relatively difficult problem that I do not see an obvious solution to it, which would make it interesting what you hear from an LLM rather than kind of expected. So that's then my talk. I think we are very close to run out of time, but please go ahead with questions. Thank you for listening.
Thank you, Paul. It was a great, interesting talk.